Okay, so to join this module, you need to have a prerequisite, which is you should already finish the stress analysis 2, 3280, yeah? Okay, now basically what does 3383 or finite element analysis do? We will deal with 1D and 2D structural and thermal problems. I will deal with software. We will use Ansys for one of our assignment. And then most of the time we will deal with a stiffness matrix, right? Later on, yeah. So today is chapter 1. So for this module, we have 3 learning outcomes, meaning what we expect you to learn throughout this semester. So the first one will be deal with one-dimensional problem, 1D problems, and then we give you a different types of elements problem to solve. After that, we will look into 2-dimensional problems, and then the last one, learning outcome number 3, will be using Ansys software to solve or commercial finite element methods package. We're referring to Ansys software. Okay, so again, if you need my help, you're welcome to contact me and meet me every Wednesday, 1 to 3 p.m. Yeah? Okay, this is the course structure that I already briefed you on the Monday. So we have 40, 60. We will have either 1 test or 2 tests, depends on your performance. And then we'll have about 4 assignments, but maybe we only have 2 assignments, right? And then exam 60%. You need 80% attendance to sit for final exam, yeah? So just for your info, you need to score at least 50% out of coursework, and then for final, you need to score at least 30 out of 100, meaning in a final exam, 100 marks, you need to score at least 30 in the final. And then when we calculate the total marks for this module, you need to score at least 50%, right? Meaning the score out of this one, coursework, you need to score at least 20 marks. Final exam, you need to score at least 30 out of 60, all right? So this one you add, you must more than 50 marks, yeah? Okay, so this is the topics that we will cover from week 1 to week 14. So today we're going to look at fundamental concept, chapter 1. We will use this 2 textbook, all right? And okay, what we're going to look at today will be look at 5 points. Most of it is just introduction steps. All right. So we look at some history. We look at what are the steps that we'll be using throughout the semester. There are only 7 steps you need to memorize. And then how we apply the FEM method. What are the advantages and what are the available programs that you can use to simulate or to compute FEM, finite element analysis. Okay, let's do some history background. Why do we study finite element? So finite element, we will look at a few types of problems. The first one is structural analysis. So when you want to deal with structure, means you consider the behavior of material under a certain forces, and forces here referring to torque, moment, and what you learn in other module in stress analysis. Yeah, so this one is more on a structural analysis. So these are the outcomes that you can get if you use Ansys software. Yeah, you can see the behavior of the stresses by all these colors, different colors. Second one, finite element method can use to solve heat transfer problems or thermodynamic problems. You can use, you know that thermodynamics, you have 3 mechanisms to transfer heat. You know that you have conduction, convection, and radiation, right? So you can simulate all these mechanism in by using finite element method. So this heat transfer will be part of your final exam question. You will be one question about heat transfer. Okay. Fluid flow. Most of the time we deal with fluid flow. In this example, what that you see on your screen here is simulating a flow throughout a aircraft, a jet aircraft. Yeah. So most of the critical point are labeled as the red color here. The fourth one, we can use finite element to analyze mass transport. Yeah, mass transport, meaning if the mass is flowing from one place to another place, then you can use finite element method to compute or to analyze the behavior. Right? In this case, you are seeing it in a two-dimensional. All right. And another one is electromagnetic potential. All right, electromagnetic. This one is more on the electrical. However, finite element method also can be used to see what is the behavior of electromagnetic wave that generated through initiation of your power in the devices. So in this one is a satellite dish. You can see that what happened if when the radiation absorbed by the panel, the solar panel, and then the radiation, the electromagnetic effect happened on this satellite. All right, so these are the 1, 2, 3, 4, 5 area that frequently you will see finite element method was used for these 5 cases here. So in chapter 2 later on, you will see we will start analyzing structural analysis, and then we will look into fluid flow, we look into heat transfer, and so on. Yeah. Okay. Now for this module, one important point or one important term that you need to know is called discretization, which is the word that I highlight on the screen here. Discretization means that you just break the structure or the component into a small pieces. In this case, on the screen here, you will see on the left-hand side or right-hand side, you will see that the component was break into a small rectangular or triangular or square shape kind of small element. We call it element. And then on the right hand side here, you will see there's a square shape, rectangular shape, pentagon, and so on. So when you learn about FEM, when you take this module, you should understand when people say discretization, or when you do your final year projects, you deal with, if you use Ansys to simulate, and you having me as one of your panel, most of the time I will ask, please explain discretization. How Ansys software run the discretization process. So you should be able to explain. Okay. However, for finite element method, you should know that we have a process called discretization. In Ansys software or most of the simulation software, this word also called meshing. Okay, we call meshing process that we will use in most of the simulation software nowadays. If you are using SolidWorks to simulate the flow or the stress on the structure, then you will go through the meshing process. The meshing process actually is a discretization process. Okay, clear? Okay, stop me if you're not able to understand the any information on the slides. Just stop me and then ask question. Okay, so far for today, the first technical word is discretization. Okay, discretization is a process where you break the component, the big component, into a small element. Okay, and then we will start analyze small element. One piece of element, we pass the information to another element, and then another element, and then another element. All right, until the last element inside the computation domain. Okay, so again, discretization is a very important word for FEM for this module. So most of the time, or sometimes you will see in your tests, or sometimes you will see in the final exam, or sometimes in your assignment also. All right. So you can see here on the left-hand side, the structure, the dam structure, the water dam structure was break into 490 triangular element. The devices that you see on the right-hand side of your screen here is a wedge that divided into 254 element, and the element is in the shape of quadrilateral element. So all these settings are important if you are using Ansys for your final year projects. Yeah? So you have to define clearly what kind of element that you use for your discretization process or your meshing process. Okay, yeah? So we keep repeating the word discretization. All right, let's look at history background. Yeah, history background. Okay, before history background, I will ask some question. Let me go to Ashmal. Are you there, Ashmal?
Yes, sir.
Okay, please explain discretization. What do you understand about discretization?
And what I understand about this discretization is like a large part. So we break it into the smaller part.
Okay, good, excellent. So
Okay.
yeah, it's a very excellent answer. All right, so we looked at a few history background. So FEM method, it was started in before the World War era, 1940s, right? But however, this one you don't need to memorize lah. But at least you have some concept. Since when this FEM method bring into the academic world or appeared in our world, it start from 1940s, 1940s, by someone called Hanikoff. And then, of course, it will start with a very simple model, one-dimensional, and then it will start with the bars and element. It will start with the stresses on a structure. Okay, now this is the name. You can Google if you're interested later on. Yeah, so this expert, Alexander Hanikoff, he's the one who try to solve one-dimensional problems on bars and beam. Where later on you will learn also in chapter 2. Then after that, someone start to use matrix. All right. So for this module, you have to be strong in mathematics matrix. Yeah. Then people start to use energy principles to solve energy problems in the structure. Then so on, people start to break into smaller pieces, where just now we learned about the discretization word. So people start to use different shape of element to solve problems. Yeah. So in 1960s, the crop tried to use triangular and rectangular element for stress analysis. So as you can see, I draw a time frame here. 1960, people start to try on analyzing a small strain because they start developing some mathematic model. And then from small strain, then people start to look at large diffraction, and thermal analysis start to consider by the scientists and the engineer. Then after people start to look at material non-linearity, for example, what is material non-linearity? People start to study plastic material. As you can see, this 1962 is industrial area. So people start to look at metals. When you pull metal, what happened? When you forge metal, what happened? All right, non-linearity, plastic behavior. All right, when you learn in stress analysis, you learn about material in the plastic form. Right, when you pull in the tensile test, there is a plastic phrases. This is a material non-linearity. Okay, then people start to look at buckling problem. Buckling, right? So buckling will cover in one of your chapter for this module, and it will be also a very popular question for your test or for final exam. Okay, buckling. And then yeah, this one viscoelasticity also discovered by some of the scientists here. Okay, so viscous elasticity is the Poisson ratio that you learn that we use to analyze structure, the deformation of structure. So as you can see here, people start to develop some mathematical models in 1960s. And then you should understand why we enforce or why we always use metrics when it comes to finite element method or finite element analysis. There are a few reasons. All right. So there are three reasons I lay out on the screen here. The first one, it is because metrics is very useful when you have a loss of equation. You can simplify the formula in the more cleaner or more structured way, right? As you can see, if you learn calculus or advanced mathematics, when you deal with metrics, you know that you can combine 3 or 2 or maybe more equation into a bracket form of a matrix. This is what you learn in your calculus, you learn in your advanced mathematics. Then it will help you to solve a longhand solution. Longhand solution means it's a very lengthy equation, but through metrics, through superimpose, through some determinants and all this, you're able to see the nature of the question, the problems that you have, whether the problem can solve or not or cannot solve. All right, and then nowadays we're already in the new era where we are having all the high-speed computer, and you know that once you have computer, you can do programming. So you can program the formula into the computer, and then means you program into the matrix form, and then you try to solve it. Ask computer to solve matrix problem for you. Where for this module later on, when it comes to a specific tutorial question, I will guide you through that. For this module, you are allowed, all right? Under my supervision, you are allowed to use website calculator to help you to solve matrix question. All right. So yeah, so because the question I ask you will be more on realistic scenario application. So I'm not testing you on the mathematics things, but at least you should understand how metrics work. Okay. Right. So at the moment, you can go to Moodle and download Appendix A from Moodle. Okay, if you go to Moodle, there's a document in the Moodle. Let me see here. So I'm opening up the Moodle for you. So here you will have Appendix A, which is metric algebra. Once you download, you open the document. All right. So we don't have time to go through all these matrix operation. Okay. So as a homework for today, please go through all these appendix to refresh your understanding in matrix. Right? What are the matrix? What are, when you talk about rectangular matrix, what does it mean? What are the row and column? How do you do matrix operation? How do you do multiplication? How do you do addition? How do you do transpose? How do you do when you have a symmetry matrix? What does it mean? What are the inverse matrix? How you do inverse matrix? Yeah, how do you do differentiating? This one I don't think you learn in your calculus or advanced mathematics, but please go through. The example is given here, so please go through all this. I believe you can read. So try to study the material. And then what are the core factor? What is core factor in this one? All right. And inverse matrix, how do you solve a matrix using row deduction? What are the row deduction method? Yeah. So property of Stiffness Matrix, this one we will learn later, right? But have a look into it. Okay. So again, so today your homework, your first homework today, download document Appendix A, read through, read through, and I assume you already know what is matrix and so on, yeah. So next lecture, make sure you're ready, what is matrix? Okay, back to our lecture. So again, download Appendix A. All right, so far everyone good? Everyone able to follow so far?
Yes.
Good,
Okay, sir.
All right, so do you guys need a break or you can continue?
Continue, sir.
Continue, so nobody want to break.
Continuous.
Okay, good. All right. I think a few more slides, then we finish. Okay, so if you learn FEM, when people start to talk about matrix, matrix is in the form of this one, right? Or if you open up the document, this is the matrix form. Something on the left, something on the right, and it represented by a bracket, and there are some row and column inside there. Okay. So for FEM, normally you will deal with forces, right? If you analyze structure, you know that you need to deal with forces. So if you want to put all the forces in the system that you're looking at, then you write capital F with a curly bracket, curly bracket equal to force at point 1, point 2, and so on. Now, what does all these small detonation? F stand for forces for this module. 1 means point 1. X mean in X direction. Okay, so just a recap what you learned in the stress analysis or in the module. Okay. So throughout this module, if you deal with three-dimensional, X, Y, Z. So all the direction to the right will be positive. If you're going to this direction, you'll get negative. If you're going up, you get positive. Going down, you get negative. Going out from the screen, you get positive. Going back into the screen, you get negative. And another one, we'll deal with the force already. So if your force is at 0.1 in x direction, you write in this way, F sub 1x. If it's y direction, you write 0.1 in y direction. Yeah. So you know that vector, you deal with a loss of vector here. So if you have a vector v, you know that you can break vector into two components. In this case, if we break the v into y and x component, you have v in x component, v in y component. Or most of the case, we will label in x, we will use u. If there is a vector in x direction, we use small u. If you have a vector in y direction, we use v, small v. And if you have a vector in z direction, we use w. Just to recall, this one you already learned in your stress analysis module. So you have u, v, and w. And most of the time you'll see again in this module. Okay. For this FEM module, you will look at force. Another one, we call it displacement. Okay, displacement. Nodal displacement means a node, a point displacement. Okay, so just now the discretization, the technical word. Second technical word for today is matrix. And expand a little bit about matrix is that you deal with force and displacement for this module. And what are the displacement that normally you need to write in your answer is that you write U1. U1 means in the x direction displacement, means the components is moving in the x direction. So we label as U. If the component move in y direction, we use a small v, w for z direction. And again, the subnote here means, if you see 1 means point number 1. Point number 2, then you denote as 2. Okay, so for this module, the presentation of your answer is very important. If you write f1x, it means something. If you write f2x, it means something. So don't confuse, because later on you will use matrix to solve problems. Okay, so up to this stage, remember, we'll deal with force and displacement. And you have two types of presentation. Curly, sorry for my drawing, I'm drawing using my mouse. You have curly bracket and you have a square bracket for this module. When it comes to force and displacement, you use curly bracket. And there are some special case that you need to use square bracket. All right, so not complicated things for today to remember. If you deal with force and displacement, you use curly bracket. Okay, memorize this one. Don't confuse. So in exam, if you accidentally you write square bracket F, straight away I cross your answer. Meaning you don't understand how to properly represent your element component. So force, you have to use your recommended or for this module if you follow along. If you talk about force, please use curly bracket. If you talk about displacement, also use curly bracket. Remember, if you accidentally you write a square bracket, D, it represents something else. So I also give you wrong for this one. All right, clear. You have force and displacement. Now we look at what happen if you use the square bracket. Square bracket usually will represent matrix, stiffness matrix, K, and we have two types of K or detonation. You will see, for example, force, you have a small f and capital F. Displacement, don't worry. Displacement for this module, you always see a small d displacement. But for force, you will have two alphabet that you need to use according to specific cases. For displacement, again, is a curly bracket. For force is a curly bracket. Force is a curly bracket. What happens if you use a small one? Small one means it is referring to the individual element. If you use a capital letter, it means you look at the global scale, means you zoom out to see the whole structure. Okay, so what does it mean? Just now you learned about discretization. So for example, if you break the square element, square structure into two elements in a triangular. So here you have a two small element here with discretization, we mesh and we break the structure into two small elements. So if you analyze element 1, you will use F. Forces on element 1, you will use small f. Same with element 2 or F1 for element. Same with element 2, you write an F like that. If you're referring to the whole component, what you write F like that. Okay. So if you write F, capital F2, it means something. It means that you have another big structure. This is element structure 1, structure 2. This one refers to structure 2. Clear? Same with the K, small k and capital K. If you write the bracket small k, it means you related to a small element, individual element. If you write capital K with the bracket, with the square bracket, it means you look at the whole structure. So K1, capital K, it means the first structure. If you write 2, it means second structure. This is 2, so you write K, capital K, 2. So if you write K, small k, 2, it means something else. It means that you're looking at this element, individual element. So be careful on how you write. Okay, and for this module is very easy to score marks, and also it's very easy to lose marks also if you're not careful. All right. Okay. Just to recap, so just now you look at force and displacement, which give you the different matrix form. For force and displacement, you use curly bracket. For matrix that you deal with structure, stiffness matrix or stiffness matrix. Okay, so just to recap, what is this structure stiffness about? If you learn physics, you have a spring structure. The spring have a spring constant, right? This one is the K for the spring. So if you pull at a certain X, it will create a force, spring force, equal to Kx. This is what you learned in the previous physics class. So if you write this kind of equation in this FEM module, you need to write carefully where if you use matrix, then you will transform into this form. Again, force, you need to use curly bracket for force. Apologize for my drawing. I'm using mouse to draw to write something on the screen. K represents stiffness. So again, remember to use square. X is the displacement. Displacement means the movement. So you write F equal to KD in this form. All right. So again, so this is the general equation that is important for today. I think the only one equation that you need to memorize. F equal to KD. Force equal to KD, but we'll keep repeating this equation and then we'll move on. So at least by now you know that when you write matrix, when you deal with force and displacement, what kind of shape of matrix you need to use. And you deal with stiffness matrix, what kind of shape you need to use. Okay, be careful. It's very important. So these are the metrics they will deal with when you study about FEM. So on the left hand side, you see is a small k, and then again the donation here K11. It means that it's a location of the matrix. K11 means column 1, row 1. This is row number 1. This is column 1. Okay. So this number is like a parking lot. So if you learn about matrix, be careful on how you park your number. So you have to be careful. So K11, it means that the number should park at this location, row 1, column 1. If you need to park your number at column 2, row 2, then you need to park accordingly. If the number referring to row column 2, row 2, please park correctly. All right. So K11, K12 represent each of the location. So don't confuse between K21 and K12. Okay. The first number referring to column, row. This is row number 2. This is column number 1. Okay. The second number is column. First number is row number. Second number, subnote there is your column. Okay. Right. Just recap back. What is matrix? How you write matrix? Okay. So in general form, you will see that you have Kij. I means row, J means column. Okay, I means row, J means column. For example, if you look at this K21, your I is 2, your 1 is Z. So if you deal with structure theory, another technical word you learn today is stiffness coefficient, or K stiffness matrix. We call it stiffness matrix, K. Okay, you only learn about 3 formula today. F equal to KD. What is F? What is D? What is displacement? What is force? What is K? Stiffness matrix. All right. So we always write our equation F equal to KD. Again, remember on the shape of the bracket that you use. So for force and D, use curly bracket. K is always a square. And if you use capital F, remember the K also capital. If you write F equal to small k times D, you get the wrong answer. Huh? It comes by a pair. It's like a computer programming. So if you write a wrong one, the program won't run. Okay, of course, this module you don't need to program, but at least excuse me, at least fundamentally you know. You know, so sometimes the student also make mistakes. They write a small f combined with capital K. Also give the wrong answer. It's also the wrong one. This is the correct one. Yeah, so these two are the common student mistakes or common error in a test answer. So normally these are the things that we see in the exam. So be careful on the notation that you use. Don't mix. So if you write capital F on the left hand side, make sure it's followed by capital K. D doesn't change. D always a small letter. All right. Okay, so this is a very jumbo size matrix. As you can know, just now we introduced you the force in a matrix form. So you can write in a column form, F1x, F1y, and then so on until the last force. K is in the matrix form, where you can have a K11, K12, and until K and N. The displacement, again, displacement is this movement or deformation in a certain direction. So if the deformation is in the x direction, you use U. Is in the y direction, you use V. In the z direction, you use W. And then the subnode there referring to the point that you are looking at. So if you write U1, it means displacement at point number 1. Okay, and you know that when you solve matrix, it must be balanced. Okay, what does it mean? It means if you want to get, if you have a 2 times 2 matrix, and you have a 2 times 1 matrix, you will get 2 times 1 matrix, for example. Okay, 2 times 2 means you have a 2 element times 2 element, 2 times 2. All right. Stop me if you're not able to understand. Yeah. So far, I think everyone is good. So again, F equal to KD. Okay, just give you some hints. So in your test, you write this equation. F equal to KD, you score 1 marks. Minimum 1 mark. After that, you expand this equation. You write F equal to something, F1x, F1y, and so on, depending on the forces you have inside the system. You write this form according to the problem that you have. You will score 1 more marks by writing the general equation. So for example, on the screen here, is you already score 2 marks before start solving any problem, before solving the question. Okay, so general equation for this module is important. Every time you solve a question, write the general equation. For example, F equal to KD. And for your information, this module, F equal to KD is a free marks. Every time you write F equal to KD, you will get 1 mark. Right? Even though you don't know how to solve, you write F equal to KD, you will get 1 mark. Yeah, so I'm going to give you hints already. I already give you 1 mark already for your test and final exam. Okay, if you look at the question, you don't know how to solve, you write F equal to KD, you get 1 mark. All right. There are 3 methods to solve. All right. So direct, variation, and weighted residual method. So this one you can look at my slides later on. Yeah. So there are three primary methods we will use throughout the module. The first one, direct method, means you will see the word equilibrium, means all the force equal to 0. Okay. The second one is variation, where we will use the principle of virtual work. This one you need to go to Moodle again. In the Moodle, there is Appendix E virtual work. You download and you will see Appendix E, Principle of Virtual Works. I want you to read also. I want you to read through what is Virtual Works. What is this? Okay, the third one is weighted residuals. This one a bit complicated, but it's one of the settings if you use Ansys software. You can select whether you want to use weighted residual method or not. So this is you balance the equation using an additional setting called weighted residuals method. So three methods. Okay, direct method. What does it mean? It means all this you can read from my slides. I will go through. So direct method is most common method that you use in your test and final exam, where you need to derive the matrix that you see in the question, right? Normally, you will start with F equal to KD. Okay, you solve the force, you solve the stiffness matrix, you solve the displacement. All right. So, example, forces. Normally, this component on the left, usually you read from the problem statement, you read from the question itself, then you extract all the forces on the left-hand side. Then after that, the K and D, this one normally you'll be given. All right. Then you solve for the missing part. Right, F equal to KD. Again, direct method is very important for this module, especially when it comes to your tests and final exam. F equal to KD. Variation methods, it deal with 2D and 3D problems, where it is very popular when it comes to simulation software. Where you see the word functional here, it means equation, right? Functional, it means equation. So variation methods, it use the loss of complex equation to solve. Weighted residuals, it use differential equation, right? Differential equation. Now, if the word differential equation, you forget already, go and Google and refresh. What is differential equation? All right. General steps. I will just brief through. If you have a tutorial question, so this slide is for question number 8. It's for question number 8. We have a few more slides. So just patient. All right. So step 1, you choose the element types. We will repeat these general steps throughout the semester. So we'll repeat until you close your eyes, you sleep also, you can explain to your juniors. So step 1, you need to start the discretization process. You mesh the element, you break into small pieces. You look at what type of element you have. Okay. Now, for example, on the screen here, you have a small cylinder. So on the left-hand side, you break the structure into 2 points. Or you can break into 3 points. Right? Most of the time, the question will tell you, or from the question itself, you'll see how many points that you need to solve. If you are seeing the left-hand side question, you only need to solve 2 points, point 1 and point 2. But if the question gives you on the right-hand side diagram, you need to solve 3 points. In the question, in your answer, you'll be seeing point 1, point 2, and point 3. Okay, so step 1, break into a smaller part. Okay, discretization. Do meshing first. Do discretization first. Meaning, you look at the structure, you break into small pieces, or normally we will break into point. Yeah, so first step, break into point. So this one is your question number 8 lah in your tutorial 1. Okay. How you can break, or in finite element or in your Ansys software, you can choose different types of element. If you deal with 2D element, then you have all the shape that you can see on the screen here. You have rectangular, you have a 2-point, or you can have a rectangular consists of 6 points. Of course, more points, it will generate more data for you. It can be more accurate, and also it can be generating more error if you key in the wrong input. All right, or quadrilaterals that you have the shape of this one, or more nodes or more points. Another one, if you go to the upper level, we call it 3-dimensional shape or 3-dimensional element. As you can see on the screen here, you have a tetrahedral, you have the hexahedral, and irregular hexahedral. So again, from today, when I mention the word triangular, trilateral, tetrahedral, hexahedral, you have to know, in your mind, you should already stand by all the shape in your mind. Yeah. So don't worry, most of the time you deal with the 2D cases. However, when you come to your assignment, when you deal with 3-dimensional problems, you will look at tetrahedrals and hexahedral. Okay. There's a reason why we don't look at 3D in your final exam, because you only have 1.5 hours to solve a question, or maybe 45 minutes to solve that particular question. So when you come to 3-dimensional, you need more time to solve because more points to solve. Yeah? So there's some logic behind the question. And another type of element types is the symmetry types. In this case, on the screen here, you'll see that you can, if you have a cylinder shape, then you can break into a symmetry plane, and then you only need to simulate that particular element. For example, on the left hand side, you have a symmetry object. Then you only need to solve this 3 point, and then you integrate according to the size that you have. All right. So you have a few types of discretization that you can do. If you're having a 2D, then you use a more simple form accordingly. If you have a 3D, then you break into all these typical or classic shape. Step number 2, you call out all the equation. Displacement function means you call out the equation. Okay, so this one, you know the equation that you learned in your mathematics or in your stress analysis. You know that you deal with linear, you deal with quadratic, you deal with cubic polynomial. Again, if you don't know what is cubic polynomial, you need to refresh. Linear equation, quadratic, cubic, meaning the highest order in the equation you have. Linear, y equal to mx plus c, or you have y equal to ax plus b. This is a linear equation. If you have quadratic, let me erase it. Y equal to ax squared plus bx plus c. This is a quadratic. Cubic, y equal to ax cubed plus bx squared plus cx plus d, and so on. All right, now because of the limitation of time we need to use in your test or final exam, we will not go more than 3 for this module. However, when you come to assignment, then you're given more time to solve, means you have a more complex problems, then the order of the equation will be increasing. All right. The second step is about the equation. The third one, you need to recall what you learned: strain and displacement, stress and strain relationship. In this case, since this is your first class, I give you the formula recap. So deformation, du dx, all right, means the change of dimension in the x direction, along x direction, du dx, and given by this epsilon x. Stress and strain always linked with modulus Young or modulus of elasticity. Stress equal to elasticity constant times the strain. Okay, so these two are the next important equation that you will see a lot of time in this module. So the next equation you see is stress-strain displacement equation, which is given by this one. Stress-strain relationship given by this one. Okay, step number 4, you solve the matrix equation. So you have 3 methods again. You have direct, energy method, and weighted method. So we will look into these steps again. Yeah. So step number 4 is on matrix. Okay, yeah. Step 1, you break small pieces. Step 2, you call out the function for that particular case. And each chapter will have the specific equation. Then you solve for the strain-stress relationship. Then you solve for the matrix. So this one you can read on my slides. Yeah. Again, download Appendix E, read through. Step number 5, you solve the matrix. Either is a global, means the whole object condition, and then remember there's a boundary condition. We will look into detail what is boundary condition. So again, at the end, you will still look at F equal to KD. F equal to KD. Then you continue to solve for unknown. Anything that missing in this matrix, F equal to KD, anything missing, then you solve. All right. Okay. So I also include another new appendix in the Moodle. We call it Gauss Method. So if you go to Appendix B, how to solve the simultaneous equation using matrix, then you go for Appendix B. Okay. Now important is that today you go and look at Appendix A. Then maybe next week we will apply Appendix B in our solution. Okay, what is important for today? Your homework is to download Appendix A, read through, and then read VirtualWorks. Appendix B optional for today, but next week we will come to Appendix B already. Okay, now this one it's just a recap how you put a simultaneous equation or equation into a matrix form. So go through. This one you already learned in your calculus or advanced mathematics. Just recap. You solve for the unknown again, stress and strain, then you explain the results. Now, when you come to your final year module, in your question or in your test question, let's say you have question 1, you have A, B, C, D. Normally the last question, you'll be asked to interpret the numbers. So for example, if you get a negative 10 Newton, what does the negative 10 Newton means? Does the structure fail? Does the direction change from positive to negative? Does it move to the left or right? You need to interpret the result. Does the result within the acceptable numbers? Right. For example, in the statement, the question itself, the maximum stress should not more than a certain number. And in your calculation, at the end, you come up with the final number, explain about the numbers. So finite element method is your final SEM module. We will look at your understanding in the numbers that you get. Okay, there will be always one question or one particular section in the question will ask you to explain what is that number means. Okay, all right. Or you need to draft, or you need to draw the behavior, sketch the behavior from your answer. Okay. Okay, all this you can read from my slides. You have structured problem and non-structured problems. For the week 1 until week 4, you will look at maybe week 5, you look at on the left-hand side question. You look at stress analysis, buckling, vibration, impact. Then on maybe the last few weeks of this semester, we will look at heat transfer. Okay, we don't have we won't cover magnetic, but we will look at heat transfer for I think the last 3 weeks of this semester. Look at heat transfer. Then we have structure and non-structured problems. Structural problems I already explained the discretization process. So these are the structures of the tower, and you break accordingly. And this will be one of your assignment problems. You'll use Ansys software to solve structural problems. Don't worry, I will guide you through. This one is another one where you'll see in the Ansys software. When you mesh the Ansys software, or when you use the SolidWorks to do analysis, then you'll go through the meshing process. This one is another one when you do meshing or discretization process. This one, heat transfer also, right? So you simulate a heat transfer inside the earth when you have a hot pipeline that transfer heat to the surrounding of the ground. Then you can break the scenario into this scenario. Okay, advantages of finite element, you can read through so you already know. This one you read through advantages. Okay, these are the rest is just an example. So this one, if you use SolidWorks to simulate a non-linear behavior for Morse stress, as you can see, if you pulling the caliber clip, the change of color represent the change of Morse stress inside the structure. This one is a wind turbine non-linear modeling. What happened to the micro crack when you have when you turn the turbine? There's a micro crack that happen, so it will become a large deformation in a structure. This one is another cases where you deal with the pressure on the housing, especially on the seal, the cap seal that you have, right? So what are the stresses at the surfaces here? Example of program that use finite element, Autodesk program, Autodesk products, AutoCAD, Nastran, and all this. So if you are in the automotive, most of the time, for example, Proton in Malaysia, most of their design engineer, they use Nastran for crash analysis. Another one is a similar also. This one is from the SolidWorks company. And then this one is Ansys, where we will use Ansys software for this module, Ansys. Cosmos M already bought by Ansys company. So this function can be found inside the Ansys software. GT stroke is structural analysis useful in civil engineering. DYNA, Dyna. LS Dyna also bought over by Ansys company. So you can find this function or these tools inside Ansys also. This one, MSc Nastran. This one popular in the industry also. ProMech also popular in mechanical engineering, especially when it comes to robotics. Then most of the time, ProMech is important. Okay, so with this, we conclude for today's lecture. So what we cover today, we cover about some history, we cover about general steps, we cover about the advantages, application, and some computer program. Okay, let me end the recording.